Hi everyone, Ms. G back with another video about equivalent expressions. So we have been working currently on the distributive property and how you can multiply things that look like this. So we have 2 times 3x plus 4. If I were going to draw this out, I would draw 3x plus 4 as 3 x's and 4 1's. And I would create 2 groups of this. So there's my original group, and then I'll double it to find my second group. And so I would say 2 times 3x plus 4 is equivalent to 6 x's and 8. I could also have done this problem by distributing, where I take the 2 and I multiply it by the 3x, and I take the 2 and I multiply it by the 4, and I get 6x plus 8. So those are the processes we've learned about multiplying. Today we're going to work on a new operation, or a new process called factoring. Factoring is when you take an expression, like 6x plus 8, and you go backwards and rewrite it as a product of its factors, or of the 2 things that would multiply to make that product. So when we talk about factoring, some people think about it as undistributing, would be another way to talk about it. Like all of our other operations, we are going to start factoring by drawing a bar model. So here's what we'll learn about factoring, breaking up into a product of its factors. And we'll start with drawing a bar model of this problem of 6x plus 18. Which I have there, 6 x's and 18. So I want to rewrite it into a product of factors. I'm going to factor it, and to do so, I'm going to think about how many equal groups I could make out of what I have drawn here, 6x plus 18. So I could make maybe 3 groups that would be equal in size, right? I could do 3 groups of 2x and then 3 groups of 6. So I could say that 6x plus 18 could be broken into 3 groups of 2x and 6. Here would be one group in blue, another group in black, and a final group here in red. So that's one way I could break this up into a certain number of groups, all of the same thing. But I could also break up 6x plus 18 into another set of groups. I could make even more groups out of this. The most possible groups I could make would be 6 groups, because I could have 1 x in each of my 6 groups, and then I could have 3 1's. So the most groups I could make would be 6 groups of x plus 3. This is an example of factoring. When you take a product, or you take an amount, an expression, and you write it as a number of groups times what is inside of those groups. Both of these are examples of factoring. So how do we know which one we're going to go for? We're always going to go for the most number of groups possible. So this is what we would call completely factored, because you've made the most number of groups possible, which was 6. Let's do another one where we only go for one answer. So in number 3, draw a bar model to represent 5x plus 15. So there's my 5x plus 15. And I'm going to look at it and I'm going to try and find the most number of groups I could make. So the most groups I could make in here that would be equal in size would be 5. Because here I have 5 x's, so I could put 1 in each group. And then I could put 3 of my 15 into each group. And that would again be 1, 2, 3, 4, 5 groups. So I could break it into 5 equal groups of x and 3. I could write this as the product of 5 groups of x plus 3. When you've factored something, we say you have undistributed it, right? So we end up with something like, that looks like what we would have if we were distributing or starting a distribution problem. And so if I go back and check, these two things should be actually equivalent. 5x plus 15 would be the same as 5 times x plus 5 times 3. So they are in fact equal, and we factored it completely because we've taken the most number of groups out possible.